Kia ora koutou. Here's one of the first questions from this year's Pure 3 Wellington College School exam. So as promised in class today, I'm going to try and just bung these out over the next 3 days. So each video should be quite short. I'm going to talk a little bit about some of the mistakes that I saw along the way. So this question, part 1, is very good practice for level 3 integration if you're doing NCEA, and then part 2 is not going to be covered for level 3, although it might turn up in scholarship, but there would be a hint given to help you do that. Okay, so let's have a read. We've got an integral, and it's given by this. So I is equal to the integral between 2 and 0 of 4t cubed times the natural log of t squared plus 1. And you can see that it's going to be a bit messy. We're asked to use this substitution to show that we can rewrite that integral in terms of x like this. And from there, we're told to find the exact value of I. Now, just looking ahead to the second part, we know that integrating log x is something that we usually have to use integration by parts for, and that's what's going to be the case here, right? So we're going to have two functions, and we're going to do our IBP stuff. Even if we don't manage to work out this part, we can still do this part if we remember how to do integration by parts. Okay, so when we're doing substitution, what we're trying to do is to switch every single thing in the integral over to the new variable. So we'll start off with I is equal to the integral from 2 to 0. Just write it out again and have a look. Now we've been told here what substitution to use. So x is equal to t squared plus 1. That gives me dx by dt is equal to 2t. Now straight away I'm going to write dx is equal to 2t dt. I'm going to pop that into a little box. And what I'm looking to do now is to somehow get dt and a 2t into this stuff here, right? So it's kind of a clue that it might be useful to split up that 4t cubed into 2 bits, into 2t times 2t squared. Now the best answers in what I just marked did that, but a lot of you didn't. And I saw some pretty mucky stuff that went a bit like this. So I'm trying to remember which way you had it. I think you had dx over 2t dt, and then you were substituting that in. Right, so that is kind of, it's a bit dodgy. We're not going to go there. We try and keep it cleaner by working like this. So we're going to be able to substitute x for this, for the t squared plus 1. We're getting somewhere with the dt. We have to work on this. And we now need to look at the limits. So the old limits were limits for t, and the new limits are going to be x is equal to t squared plus 1. So this was really, really well done. And most of you used the table. So 4 plus 1 is 5, 0 plus 1 is 1. The new limits are 5 and 1. Right, so the integral is now going to go between 5 and 1, and we're going to have 2t. Let's just write it up here. So 4t cubed is equal to 2t times 2t squared. We need to find a way to get t squared in terms of x. Right, x is equal to t squared plus 1. That gives me t squared is equal to x minus 1. And we're going to substitute that in as well. But I think I'd like to have a line of working that shows that before I switch my limits over. Remember that in a proof question, you want the person reading it to be able to see exactly what you did. So let's just rewrite it again, keeping it in terms of t. And we're going to have 2t squared times 2t times the natural log of t squared plus 1 dt. Now it's really, really obvious what I'm doing here. And we can change over our limits now. So the limits are now 5 and 1. I'm hoping some of you probably would have put this on double speed already. So 2t squared is going to be 2 times x minus 1 times ln of x. Replacing that, and the 2t and the dt gives me dx. Right? which is almost exactly what we need. 2x minus 2 times the natural log of x dx as required. So that was worth 3 marks, and if you were confident with substitution, that question was well done. Things that I saw that were really time wasting were, for example, getting t is equal to the square root of x minus 1, and then having a whole bunch of square rooty stuff that just needed more algebra. Every time you put in unnecessary algebra, you increase your chances of mucking it up. So let's get on with it now and integrate this. Well, we know that this can't be integrated easily, so this is going to be the function that I leave. This will be the one that I integrate. And here in the second go round, I'm going to integrate this one again and differentiate this. Now it is, I think, cleaner in this case to just leave this as a single function. Some of you split this out into 2 integrals. So you did 2x ln x dx minus the integral from 5 to 1 of 2 ln x dx. Now that's fine as long as you don't muck it up, but it means you're going to have to end up doing integration by parts twice over, which is kind of painful. A couple of you tried to do that and then you completely forgot about this second integral, so that didn't work out so well. Okay, so the first step of integration by parts is to integrate 2x plus minus 2. That's going to give me x squared minus 2x times the other function, the natural log of x, evaluated at 5 and 1, minus the integral from 5 to 1. So integrating this again, we get x squared minus 2x, and this time we're going to differentiate the log of x. So we get 1 over x dx. You can see that that's going to clean up really well. I'll just copy this one down again, and I'll do all of the substitution at once. You can do that as you please, but that's usually how I do it. And then in here, we've got the integral from 5 to 1 of x minus 2 dx, which is a very easy integral. So now we're going to have the first integral minus a half x squared plus 2x, all evaluated where we need to do it. So it's finally time to substitute. For the first term, we're going to get 25 minus 10 times the natural log of 5 minus 25 over 2 plus 10 minus, and then in brackets 0, because the log of 1 is 0, minus a half plus 2. Right, when we clean all of that up, we get 15 log 5 minus 25 over 2 plus a half gives me minus 12 plus 10 minus 2, and we end up with a final answer of 15 log 5 minus 4. Okay, so that was worth 5 marks. If you go on to Google Classroom, if you're in 13 MCA this year, you can see my work solutions for this, but also the mark schedule that this came from. So I think this was from, I'm trying to remember what year this was. It'll tell you in the schedule. It's quite an old question. I really like it because I think it makes you do substitution, and I know a lot of you often avoid doing that and just try doing reverse chain rule. Thanks for watching. I'm going to do some of the complex numbers ones soon.